today I'll show you how to create a agentic AI-driven system, AI-driven triage system using Knative Eventing. Let me walk you through the pipeline we have here that I wanted to have. So the first step is customer sends a message. So to the intake service. This service is exposed to the internet, to the outside, and clients or customers, they can interact with the service by sending a message, by sending a raw text message actually. And then this will trigger a pipeline which goes like this. First, the intake service creates a new task, so it creates a new cloud event. This cloud event will be processed or will be consumed by the structure processor, which will extract key data from the raw message, like the person's name or email and things like that. And then it will create a new cloud event, which will be consumed by the Guardian service, which checks if the content is safe or not. If the content is clean, we create a new cloud event, checking, getting the customer information and checking if this is a known customer. And finally, we route the message to the correct system, finance, support, website, blah blah, all these systems. And if at any step we are not sure, or if we don't if there is some bad words or things like that in it, then we send the message to a manual review queue. So this structure, this demo might look familiar because it was built on top of Burr's AI message triage demo. Here Burr is using pretty much the same services, or we are using the same services as Burr, like structuring, Guardian, customer lookup, and etc. Here Burr's services were talking directly to Kafka topics. They had the services, they had logic to consume messages from Kafka topics. They needed to know which topic they need to talk to and things like that. But we thought we can do better with Knative Eventing. In Knative Eventing, we use EKB, which means Knative Eventing Kafka Broker. This is the central piece. So this does the message routing, or cloud event routing, I should say. And services can subscribe to different cloud events. When the user sends a new message to the intake service, the intake service will create a triage.intake.new cloud event, and it will send it to EKB, the broker. And then the broker will route this to subscribers of this cloud event, which in this case is this structure processor. Structure processor will do something and then create a new message, example triage structured, and it will go on like this. Let's check how it looks like in the OpenShift console. So we have the serverless services here, Knative serving services here. So they are currently all scaled down to 0. The structure processor, Guardian processor, etc., and also the intake service. So these are all Knative services. And we also have 3 additional deployments. One is for the database, the customer database. The customer lookup service is using this database to check if the message is coming from a known customer or not. And there are 2 additional deployments. One is the UI observer. This is just a simple UI. Let me refresh. So this will show if there is this one on the left, the UI observer, will show all the cloud events that the broker receives. And the other one, the finance responder, it's this one. It's called the finance department inbox. If the message sent is related to finance department, it will this UI will show it. So as I said, these services are scaled down to 0. Let's send a message that is not related to finance. So my name is Jane Doe and I'm logged out of my Gizmo X account. My email is blah blah blah. Let's send this one. And you can see already the intake service scaled up, and then the structure processor and the guardian blah 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 goes like this. And let's check the UI observer service. So intake.new triage.structured, it goes like this. So for this message ID, this is the correlation ID, we have 5 different cloud events that are sent. In the finance department, there's a bug here which shows like duplicate messages. This is still the previous message, so since I didn't send a finance related message, there is nothing new added in the finance inbox. But now let's send a finance related message. I need to dispute a charge on my last invoice, etc. So my email is John Smith. Let me send this one. So here you'll see there's a new swim lane, and in this case intake new, structured, guardian passed, customer found, and finally routed dot finance. Since it's a finance related message, I now see new message here that the finance department needs to take care of. So here currently I only have the archive button, but imagine, you can have more messages. You can have more buttons, you can have more actions here. So this is all great, but as I mentioned before, the big benefit is loosely coupling. That is the first thing. And the second one is, your services, like none of these services, they know about Kafka. They know nothing about, message ordering or anything like that. They just get cloud events, which are in the end HTTP messages. They just get HTTP messages and they reply. So let's check, for example, the structure processor's code. In the end, it's 140 lines of code. So this is this first part is the LLM calling part, and this is the entry point. The structure processor in the end is a HTTP server, right? And it will receive a cloud event over HTTP. It will parse it, and then it will call the LLM, and then it will reply the request with new response headers and new response body. The response headers will be like the CE means cloud event. These are cloud event headers, like this is the cloud event type, like com example triage structured, and the body will be whatever we receive from the LLM call. So this makes things a lot easier for when you think about the development time. You don't have to think about any Kafka. You don't have to think about where do I read messages, where do I send them. You just get events and reply. That's all. So we believe this is a really highly scalable and loosely coupled system. It's a really it has a simplified architecture, and most importantly for AI workloads, it's also cost effective, allowing the resource intensive agents, if there are, to sleep until they are needed. The code is available on K Event Mesh Organization Agentic AI demo repository. Thank you.